Okay, so in this simulation circuit, we are going to assess the effect of temperature on the thermistor's resistance. And in front of you, from the right hand side of the screen, I am going to increase the temperature, you can see. And as I am increasing the temperature, the resistance is decreasing of the thermistor. You can easily see. And what is its impact on the parameters of the circuit? Please understand that very well. Please understand that very carefully. So as the temperature of the thermistor is increasing from 130 to 140, 142, 143, 145, the resistance is decreasing. And when the resistance is decreasing, we know that the voltage is directly proportional to resistance. So since resistance is decreasing, so the voltage shared by the thermistor, which is VT, is also decreasing, as you can see. And in order to keep the Kirchhoff's voltage law conserved, because we know that the supplied voltage is always shared by the resistors. So if thermistor is eating up a little or consuming a little voltage, the other should be in consuming more voltage, right? So we can easily see that this is actually happening. So let's take the other look around. I'm reducing the temperature. So when I'm reducing the temperature, what is happening? The resistance of the thermistor is rising, and therefore the voltage share of it is also rising, because V is directly proportional to R according to Ohm's law when temperature is not constant. Okay. So since the voltage share by the thermistor is rising, the voltage share of the fixed resistor is decreasing, which is V. And since the overall resistance of the circuit is rising because both resistors are connected in series, so when both resistors are added up and the total resistance of the circuit is rising, the total current of the circuit is falling, because current is inversely proportional to resistance. So again, I take a look, the inverse effect of it. So when temperature is rising, as I'm sliding it, you can see. So when temperature is rising, the resistance of the thermistor is falling. So when resistance of the thermistor is falling, the total resistance of the circuit is also falling. Therefore, the current is rising. And when the temperature of the thermistor is rising, the voltage across the thermistor is also falling, right? Because the resistance is falling. And since KVL says the voltage supply is always equals to the voltage shared by the components, so since one component is taking up less voltage, so the fixed resistor should have a greater share of the voltage. So that is actually the application of Kirchhoff's voltage law and the thermistors and temperature relationship with rise and fall of the temperature. I hope you understand that well. Thank you.